Hello and welcome to this session. This session we will see LM35 analog temperature sensor. So this is very basic and popular sensor, and the reason is it's very affordable and has very minimal connections. Also, this temperature sensor gives output directly in degree centigrade. So in this experiment we will display the temperature values read from this LM35 and display it on our LCD screen. The same experiment can be slightly modified for any other analog sensors or can be further modified to serve as Internet of Things. We have so let's get into the datasheet of LM35, which I have opened here. You can see the straightaway features. It says it's calibrated in degree centigrade and it's a linear nature, 10 millivolts per degree centigrade. Suppose a temperature raise from 30 to 33 degree, that means there will be a 30 millivolts change in analog voltage. And the range is quite good, minus 55 to 150 degrees centigrade. And also the operating voltage is quite good, 4 volts to 30 volts. Anyway, we will not get into the complete data sheet. All we need to know is read the values, read the number of samples received from LM35, convert it into voltage, and hence get the output in temperature, degree centigrade. So if you are interested in data sheet, which you should be, because it's a very good practice to go through a data sheet before assembling any hardware, you may visit this page, ti.com/lit/ds/simlink/lm35.pdf, or you simply search in your search engine and you will get probably in the first result LM35 datasheet. So let's move further and let's come to this Arduino IDE. Okay, so here in the live feed you can see, we will discuss about this markers 5 volts and 1024, but before that you can see the LM35 is connected right here with right probe connected to ground and left probe connected to VCC through this red wire, and the center wire is connected to A0. So this is in line with our bridging circuit, which you have seen right here. Fine, so this bit of explanation you might be interested. So any microcontroller is a digital device. It cannot understand analog voltages at all. All it understands is 0 and 5 volts. 5 means 1, 0 means 0 logic. But LM35 is a temperature sensor. As you know, the Atmega 328 IC, which is this used in Arduino, has inbuilt analog to digital converter. That means this IC can handle analog voltages. This much you already know. So coming to the scale, you can see the analog to digital converter inside microcontroller is this portion, and this is the analog voltage provided by LM35. So let me give separate colors to both of them so that we can easily. So let me give yellow for LM35 and green for digital voltage, which we have already given. So any change in voltage, any change in analog voltage in LM35, any change in analog voltage will be either the range 0 to 5 volts, because we are giving a reference voltage of 5 volts through this wire, you can see. So the maximum voltage it can read or it can send to Arduino is 5 volts, and minimum it can send is 0 volts. And the analog to digital converter inside Arduino, the peripheral somewhere inside microcontroller, can sample it to 0 to 1024. You may ask me why 1024, because as you know, this Arduino Atmega 328 microcontroller is 10-bit ADC, So 10 bit means 10 bit is 2 raised to power 10, which is 1024 samples. As you know, 10 bits can means 10 times 1 in binary, and 0 means 10 times 0 in binary. So any value in between correspond to respective voltage read from the LM35. So let's go through this once again. So suppose our temperature sensor reads a value, and that value corresponds to some say that value corresponds to 1 volts. So it will be somewhere here in analog scale. The analog to digital converter here inside microcontroller will convert this 30 degree centigrade to equivalent, this 1 volt to say some 30 samples in digital. So out of 1024 samples, say 30 or 35 corresponds to 1 volt, or maybe 1 volt will be somewhere around 200, of course, because if you calibrate likewise it will be around 200. Similarly, 2.5 volts somewhere here will correspond to 512 samples likewise. So the digital samples are linearly correspond to analog samples. Now coming to programming, so let me keep this live feed ready and let me clear few markers. Okay, so we need not need any reference now. So I have already kept the template ready. So this template for LCD you already know, no need to explain again. And for this analog read, we don't need any external library. So this liquid crystal is good enough. And for void setup, here the analog pin A0, which is here, A0 is configured as input because we are reading value, and the LCD.begin you already know, we are initializing the LCD in the setup function. So in the void function, which is an infinite loop, what we will do, we will take a we will read the values. First of all, analog read A0. So this will read directly the values coming from LM35. So these values we have to store somewhere. So let me put it in a variable float samples. So why samples? Because Arduino will internally convert this analog read data into number of samples. As you know, the sample from 0 to 1024, 10-bit ADC. So this 10-bit ADC samples, so let me write it down, it will be easy to understand. So each digital sample, we know that maximum it can go up to 5 volts. So each digital sample could be 5 volts divided by 1024 volts. Do you agree this? So it's as simple as that. So 5 volts is the maximum analog voltage and 1024 is maximum digital number of samples. So 5 volt value will be converted into 1024 in digital. 5 volt is analog, 1024 is digital binary. So we want to know how much voltage is there in each sample. So we have total 1024 sample. So each digital sample has 5 volts divided by 1024 volts, and this will be in some millivolts. So let's find it programmatically. So let us name that variable as, say, float analog voltage of, say, samples. So this equals to samples, which we already read, into 5 divided by 1024. Okay, so semicolon. I hope you understood this part. We will come back again at the end of this during revision at the end of the session. fine. So also, so this voltage analog, this variable, what does it has? Analog voltage of samples. So before that, let me do one more thing. So let me comment this also, and let us LCD dot set cursor 0, 0 and LCD dot print samples. So I want to show you that how this looks when we just print the samples. So you can see it's around 62 degree. Okay, so let me put some delay. Why we need a delay? Okay, so I hope most of you have figured out, because this void loop, this infinite loop is very fast, it iterates very fast, so the screen appears flickering, right? So we'll put 1 second delay. So 1000 second is 1 second delay, and let's upload this program. Now you won't find it flickering, but I think is the value here. Let me zoom it and show it to you. I hope it's better. So what is this 62? So 62 is out of 1024. If you remember that scale which we have which I have shown you earlier, we have a digital scale of 0 to 1024 corresponding to 0 to 5 volts of analog input. And this 62 or 63, whatever value we are getting, is the number of digital samples corresponding to analog input. Okay, so what would be the minimum samples you would have got? 0 samples. And what would be the maximum? It will be 1024, because it's a 10-bit ADC, right? So 63 is very less analog voltage. You can say the temperature value sensing is sensing some low voltage, you can say. But this is not actually the voltage, we have to convert it. So fine, so this printed the samples, but we are not interested in samples, we are interested in, so let me uncomment this and print this analog voltage of samples. Okay, Control U to upload. Fine. So it shows 0.30. So 0.30, as you can guess, is if you multiply it by 100, it will become 30, and 30 seems to be reasonable temperature. Yes, it's hot in here, because I have to turn off my fan and AC, but that's how it works. It's 30 degree of my present room temperature. So how to convert it? Coming back here, let me write a small comment. So we know each 10 millivolts, and the 10 millivolts we can write 0.01 volts, right, given by LM35 is change in 1 degree centigrade, correct? So how many such degree centigrade we have in our given voltage? By read from LM35, right? Okay, so for this we have a simple solution. So let me define a new variable of float type. Float temperature equals to we have our analog voltage of samples divided by 0.01. Is this clear? If not, it's very simple. Because this analog voltage of samples are in voltage scale, we have to convert our millivolts into volts, that is 0.01. So actually what we are trying to find here is how many such degrees centigrades, means how many such 10 millivolts are available in our given point 30. So 0.31 is actually the voltage we read after converting the digital samples into equivalent voltage. So we want to know how many such 10 millivolts samples can be accommodated within this. So analog voltage of samples divided by 0.01. So this will give us the temperature value, and I accidentally kept it here. So after this statement we will set the cursor and print. Control U, and it's okay. I have to change this to temperature. So it gives 30.26, 27, etc. reading every second. Let me further modify lct.setCursor. Let me make 7th column, and I will just print here degree centigrade just to make it more appealing. lcd.print. Okay, Control U to upload. So 30.27 degrees centigrade. So this is converting LM35 analog output into digital and then displaying on LCD screen. I hope you understood the program and the logic. If not, we will do a quick revise. So let me show you how this temperature works. I like to play with it always, and let me hold it tight, and you can see there will be a sudden rise in temperature. So it has changed from 30 to 32 point, oh, once it went to 35. Hey, so it is becoming normal now. It will drop till 30, I guess 30 point something. Anyway, we'll play with it later. Let's get into program once again, how it works and what is this. I hope need not to explain this liquid crystal, because this we have repeated several times. Setup, we are setting up analog input as A0. LCD.begin is 16x2 format. Number of samples, as you know, there are total 1024 samples, digital samples converted from any analog input, because we have 10-bit ADC in Atmega 328. So Arduino supports 10-bit resolution of ADC. What is a 10-bit resolution? Any sample, any analog sample will be displayed with 1024 samples in digital. Suppose you have 0 volt as analog input, you will get 0 as the digital output. If you have 5 volts as analog input, you will get 1024 as digital output. So it's just one-to-one mapping, which we have seen earlier in this video. So here we have calculated number of samples. We collected number of samples. So each digital sample has 5 volt divided by 1024 volts. So we are actually trying to find out what is the voltage equivalent of samples received. Okay, because we know 5 volts corresponds to 1024. So how many volts corresponds to our number of samples? If you remember, we received something like 60 here, right? So that voltage is analog volt of samples. Okay, so name is also familiar. Analog voltage of samples is something came 0.31. Also, we know that 0.31 volts is the total number of temperature actually, because we know 10 millivolt of change in temperature corresponds to each degree change. That's why we have to divide it with 0.01. What is 0.01? It's a voltage itself. So 10 millivolt is actually 0.01 0.01 volts. Okay, so how many such 10 millivolts are there in our analog samples, analog voltage? That we have to just divide it by 10 millivolts and we'll get the temperature. So this temperature is nothing but number of such 10 millivolts in our given sample. Then it's everything simple. Set cursor to 0 column 0 row, print the temperature, set cursor to 7th column 0th row, print degree centigrade, give a 1000 millisecond delay. I hope you understood this tutorial. If not, feel free to discuss on forums. See you in the next video. Bye.